Now, we're going to take up one more problem. The problem number 33. Draw the SFD and BMD for a simply supported beam of 6 meters long carrying a UDL of 2 kilonewton per meter over the entire length. So we have 6 meter length of 2 kilonewton per meter for the entire length and point loads of 5 kilonewton at 3 meters from left support. So 5 kilonewton from left support, that is 3 meters. Then 4 kilonewton from 4 meters from left support. So 4 kilonewton here at the point D, which is 4 meters from left support mean. So from A to D will be 4, but it is from A to C it is 3. So naturally from C to D it is 1 meters. Then and 3 kilonewton. So 3 kilonewton at 5 meters from the left support. So 5 meters means, so from here to here, it is 3 plus 4, 1 plus 1, it becomes 5. So 5 meters from the left support. And draw the shear force and bending moment diagram. So first we are going to find out what will going to be the support reactions. So taking the moments about the point A, so we will going to have RBV into 6 will be equal to 2 into 6 into 6 by 2 plus 3 into 5 plus 3 into 5 plus 4 into 4 plus 5 into 3. So that will be on simplification. You will going to get the RBV as 13.67 kilonewton here. And also we know RAV plus RBV will be equal to 2 into 6 plus 5 plus 4 plus 3, which will be equal to 24 kilonewton. Therefore, RAV will be equal to, substitute the value of RBV as 13.67. So 24 minus 13.67, which will be equal to plus 10.33 kilonewton. So RAV will be equal to plus 10.33 kilonewton. So now we will going to write the shear force diagram. So what will going to be the shear force at the point A? The shear force at the point A is acting upwards. So the report reaction is acting upwards. Section to the left side which is acting upwards, the load will going to be the positive value by sign convention, which will be equal to plus 10.33 kilonewton. SF at C will be equal to 10.33 plus 10.33 minus 2 into 3 minus 5, which will be equal to minus 0.67 kilonewton, which is at the point C. Similarly, SF at D will be equal to minus 0.67 minus 2 into 1 minus 4. So that will be equal to minus 6.667 kilonewton. Then SF at E will be equal to minus 6.66 minus 6.67 minus 2 into 1 minus 3. So that will be equal to minus 11.67 kilonewton. SF at B will be equal to minus 11.67 minus 2 into 1, which will be equal to minus 13.67 kilonewton, which is at this point B will be having plus 13.67 kilonewton, which is acting upwards. So now this is how it will be having the variation of the shear force diagram. So when you want to analyze this in shear force, we can see here SF at A is 10.33 kilonewton. SF at C, just before C, you have an UDL. At the point C, you have UDL and also the point load. So when you are plotting, first we need to consider the shear UDL, and then we have to apply the point load. When you are considering only the UDL, SF at C will be equal to plus 10.33 minus 2 into 3, which becomes 6. So 10.33 minus 6 will be equal to 4.33 kilonewton. So therefore, here what happens, because due to the UDL, SF drops down from 10.33 kilonewton to 4.33 kilonewton, drops down in the plus positive direction. But due to the presence of the point load at the point C, which is minus 5, so that will be minus 5 is taken, that will be equal to minus 0.67 kilonewton. That is, the SF changes from positive to the negative value. SF at D will be equal to minus 0.67 minus 2 into 1, because you have UDL and also the point load at the point D. But first we consider only the point load, only the UDL. Therefore, that will be minus 0.67 minus 2 into 1, which will be 2. So it comes down to 2.67 kilonewton only because due to the UDL. And also the further there is 4 kilonewton load is acting downwards again at the point D. So then it is drastically drops down to minus 6.67 kilonewton. That is because due to the point load applied at the point D. Similarly, SF at E will be equal to 6.67 kilonewton minus 6.6 kilonewton minus 2 into 1 minus 2 into 1. So it will be minus 6.67 kilonewton minus 2 into 1 is 2 kilonewton. That is equal to minus 8.67 kilonewton. Because due to the UDL, it drops down from 6.67 kilonewton to 8.67 kilonewton. Again, at the point E, you have the 3 kilonewton is also acting. So therefore, so again, it is acting downward. So it will be negative value. So 8.67 kilonewton minus 3 will be minus 11.67 kilonewton. Now from 11.67 kilonewton between E and B, which is minus 11.67 kilonewton minus 2 into 1, it will be minus 13.67 kilonewton. Again at the point B, because due to only to the UDL, SF drastically reduces from 11.67 kilonewton to 13.67 kilonewton. At the point B, you have the plus 13.67 kilonewton. So this is how it will going to varies the shear force diagram. That is what we have given the explanation, which is plus 10.33 kilonewton to plus 4.33 kilonewton linearly due to UDL and drop suddenly to minus 0.67 kilonewton due to the point load at C. Then again minus 0.67 kilonewton to 2.67 kilonewton because due to the UDL and drop suddenly to minus 6.67 kilonewton due to the point load at D. Again varies from 6.67 kilonewton to 8.67 kilonewton because due to UDL and drop suddenly to minus 11.67 kilonewton because due to the point load at E. Similarly, from minus 11.67 kilonewton, it drops to minus 13.67 kilonewton because due to UDL. So since it is the UDL and the point load, so naturally all the lines what you join, it is going to be a linear line. Now we will go for the bending moment diagram. So bending moment at the point A will be equal to 0. Bending moment at the point C will be equal to plus 10.33 into 3 minus 2 into 3 into 3 by 2. On simplification, you will going to get it as plus 22 kilonewton meter. So BM at D will be equal to 10.33 into 4 minus 2 into 4 into 4 by 2 minus 5 into 1. On simplification, you will going to get it as 20.32 kilonewton meter. Then SF at E will BM at E will be equal to 10.33 into 5 plus, that is plus 10.33 into 5 minus 2 into 5 into 5 by 2 minus 5 into 2 minus 4 into 1. So on simplification, you will going to get it as plus 12.65 kilonewton meter. BM at B will be equal to 10.33 into plus 10.33 into 6 minus 2 into 6 into 6 by 2 minus 5 into 3, then minus 4 into 2 minus 3 into 1 will be equal to 0. So when you plot this, you will going to get BM at A as 0, BM at C as plus 22 kilonewton meter, BM at D will be equal to plus 20.32 kilonewton meter. So then again, BM at E will be equal to plus 12.65 kilonewton meter and BM at B will be equal to 0. So all these points will going to have the parabolic curve. So maximum bending moment will going to occur at the point C because where the shear force changes its sign from positive to negative. So you will going to get it as plus 22 kilonewton meter where SF changes its sign at C. So this is how you will be able to analyze and Find out the support reactions and also the shear force diagram and the bending moment diagram for the simply supported beam with a set of point loads and uniformly distributed load over the entire span. Thank you.